Hello class, welcome to today's lecture video. In it we're just going to cover examples of finding the first derivative with an emphasis on doing functions that have a product or quotient rule or a combination of the two inside its structure. So let's have at it. Find y prime given part A. Y is x squared times e to the x plus 2x plus 1. So in looking at this piece here, we notice that it's the sum of two parts. This part is going to require the product rule because we're multiplying two functions together, but because differentiation just happens term by term by term, I'll just take the derivatives of these two polynomial pieces separately and combine the results. So pulling this piece off on the side, we could make our labelings for the functions f and g as follows. So the first function x squared and the second function e to the x, these two functions have first derivatives of 2x and e to the x respectively. So the product rule has us multiply one function by the other's derivative, and we add that to the derivative of the first function multiplied by the second. So then I'll pull the solution off over on the side here. If y is this function, then y prime is the product of those two pieces, x squared times g prime. And then we add along 2x multiplied by e to the x. That handles the first two pieces of this part alone. And then we continue down and say, what's the derivative of 2 to the x? That results in 2, and what's the derivative of a constant? Constant vanishes, goes to 0. So then that's our first derivative for part A. For part B, it's similar in the idea that we could have sums and differences of different functional components that require the use of different rules. So in this first instance, we need to make use of the quotient rule, and in the second one, the product rule. Okay. So for the first one here, we identify the functions f and g, just looking at this piece in front. The numerator, or high, is x plus 1, and the denominator, or what's low down below, is x squared plus 1. And their first derivatives are 1, and g prime is 2x. So I'm dropping the function notation f of x here, just mainly because of board space. But we have a function and its first derivative. So when we move over across the way and start calculating the first derivative, we do low d high. So low, or g, x squared plus 1. D high means the derivative of the numerator function minus high d low, 2x. And then we square what's below, we would square the function g. And so for in these first few problems that we're just computing the derivative using the formula, I'm not going to require you to expand or simplify it, although it's not too hard to do it in the numerator because negative x times x is negative 2x squared, which could cancel with one of these, and 1 times anything is the anything. It's not too hard to do. But this is the correct form for the quotient rule here. Now we move on to this piece here, and maybe we could do it a little faster. But if you like, you could always pull it off the side. The only modification that I'm going to want to do at the start is algebraic. Recall that if we have a logarithm, including the natural log of x to a power, we could drop the power down in front. So I'll just do an erasure here, drop that 2 down in front. That's not a calculus move. That's algebra move to make it look like the product of two distinct functions with no composition done there. Okay, so again, you could either on the side build yourself your own chart with those two functions, or just start to remember the structure of the rule. So this is the first function. Let's take a derivative of 2x. What's the derivative of 2x? Well, that would just be 2. So we've differentiated this term, so then we just have to leave the natural log function alone and copy it down. Now we pivot, we differentiated this one and left this one alone. So now this is the function that we have to differentiate, the second one, and we have to leave alone the first function. So we copy down 2x and we multiply it by the derivative of natural log, which is 1 over x. So I suppose though, I will do just a little bit of algebra here because I do want to clean up this piece here. So let's handle this. As I said earlier, when I multiply it out, it becomes negative 2x squared, and then right here, those products, negative 2x. And 1 times anything is the anything. So then those two are like terms. We would have negative 2 plus 1 minus x squared. There's no other single power term there. And then 1 times 1 is just 1. And you could leave the denominator alone. Over here, it would be plus 2 times the natural log function, and then the x and the 1 over x cancel, leaving you with just 2. All right, so for example problem 2, we're going to return to a traditional problem model. That is, find the equation of the line tangent to this function here. So we've done example problems like this before in class or in other lecture videos, but now we're just going to add on to the new tool, the new rule, that is, our function naturally presents as the product of two terms. But regardless of that, the same structure as before, since our target is to find a line, we need to load up the equation of a line that we use in calculus. That is the point slope form. So here, x naught is given, is the value 0. So x minus 0 just returns x. The value for m has to be, we take the first derivative after we get it as a function, then we plug in 0, the given x point, and the y value, y naught, is acquired by substitution of x naught into the function. So notice here, this isn't too bad to do. If we substitute in 0, the first term of the product just returns 1, 0 plus 1. So this is 1, likewise 0 cubed, 0 and 0. The second factor just returns 1 again. 1 and 1 give us 1. So our y value is 1. So we have most of the pieces of this puzzle by plugging in 0 here and 1 over there. Now we just have to do the new thing, that is take the first derivative of this using the product rule. So the two pieces, for those of you that still like to use charts, but I will then start to reduce the amount of stuff I write above as we get more familiar with the structure, is first function, second function. We take the derivative 2x, we take the derivative 3x squared plus 4x plus 1, and we need to multiply those two functions, the first times the derivative of the other one, and then add that to the product of those two functions. And that will be f prime of x. All right, so carrying that through, the first derivative is x squared plus 1 multiplied by 3x squared plus 4x plus 1, and then plus, but I'm out of board space, so I'll drop the next summand down below. That's 2x multiplied by x cubed plus 2x squared plus x plus 1. Now we need to find m, the slope, by plugging in 0. But again, plugging in 0 makes a lot of these factors really easy. This first term becomes 1, 0, 0, 1. So this first piece in the summand is 1. And then here, if I plug in 0, that vanishes. 0 times anything is 0. So that becomes the value 1. So we could then update our formula. After processing down to this point, we just need to plug in the value that we got for m, so that y minus 1 is 1 times x. And this one's really quick to put it into the mx plus b form. So we'll close out with that. That's the equation of our tangent line. All right, so our third and final video, I'm going to try to make this as interactive again as possible in this format. But I would like you to, in a moment, pause the video, like hopefully you've done in the past, and try your own hand at this problem. Same as our previous example, but this time around, our function naturally presents as a quotient. So find the equation of the line tangent to this function at the value x, or x naught if you will, x is 1. All right, so 3, 2, 1, pause the video, try it on your own. All right, so there's the solution to this problem. Take a look at it, review your work. Hopefully you got it completely right, or it's easy for you to figure out where an error was made. But at the end of the day, this is the equation for the tangent line after we've gone through the steps like we outlined before, except the only difference is that the structure of the first derivative is acquired by applying the quotient rule. But in any case, take care, class. I'll see you soon. Bye.